Solving systems of equations using substitution. I'm on page 283 in the math book if you would like to turn there and work these out. The first thing that you do is you have to isolate a variable. It does not matter which variable you choose, but you have to isolate a variable in order to substitute it into the other equation. Now, for the first 6 of these problems, it's already done. Both of them are already in slope-intercept form. When they're both in slope-intercept form, it's actually very easy. You just take y is equal to x minus 1. So where y is in the other equation, instead of writing y, you're going to write x minus 1 equals 2x minus 4. So you're going to set what y is equal to. You're going to set these two expressions equal to each other because you're taking y equals x minus 1 and you're plugging that x minus 1 into the other equation. Remember, we have to plug it into the other equation. So when we solve this, remember when you have a variable on both sides, first thing you do is look to see if you can combine like terms on the left side. If you can simplify anything on the right side, I can't do anything, so I'm going to move my variable first. It does not matter which one you move. I'm going to pick x and subtract it from both sides. That leaves me with negative 1 equals 2x minus x is x. I'm bringing under minus 4. To get x by itself, I add 4 to both sides. And I get that 3 is my x. Your second step is to take the value of 3 and you're going to plug that into one of the equations. It doesn't really matter which one you plug it into. So I'm going to plug it in right here for x. Y equals x minus 1. So y equals 3 minus 1. 3 minus 1 is 2. So y equals 2. And if I had plugged it into this one, I would have gotten 2 times 3 is 6, and 6 minus 4 is 2. So I still would have gotten the same thing. Once you have solved and gotten 2 values, one for x and one for y, then you're at your ordered pair. Your x is 3. Your y is 2. That is your solution. And you can plug it in and check it. My y is 2. 2 equals 3 minus 1. 3 minus 1 is 2. 2 equals 2. So I know it's the solution for that one. The x is 3. 2 times 3 is 6. 6 minus 4 is 2. 2 equals 2. So it's the solution for that one. So that's number 1. And number 2. I'm going to do the same thing. I'm going to start off with isolating variable, which has already been done. So I'm going to take this x plus 2, and I'm going to plug it in for y, because y equals x plus 2. I'm going to plug that in for the other equation. I can't simplify anything on the left side, and I can't simplify anything on the right side. So I'm just going to add x to both sides to get the variable on one side. X plus x is 2x. Bring everything else down. This is a 2-step equation. I'm going to subtract 2 from both sides and divide by 2. And I get that x equals 4. I'm going to plug that 4 into the equation. It does not matter which one we plug it into. So I'm going to do y equals 4 plus 2. 4 plus 2 is 6. And the reason I say it doesn't matter is y equals negative x plus 10, and negative 4 plus 10 is also 6. So you're going to get the same thing. The only thing where it matters is once you isolate your y, that has to go into the other one. But when you get that x equals a number, you can just plug it in. So 4, 6 is your solution, and you can check it. My x is 4, 4 plus 2 is 6, 6 is my y. my x. Negative x plus 10 is 6. 6 is my y. So I know that this one is correct. Alright, number 3. Again, we are going to plug this in for y on the other side because it's already isolated. Negative 3x minus 6 equals 2x minus 1. I'm going to add 3x to both sides. Negative 6 equals 2 plus 3 is 5x minus 1. I add 1 to both sides and I'll get negative 5 equals 5x. And then when I divide by 5, negative 5 divided by 5 is negative 1. And that is my x. Plug it into one of your equations. I get y equals negative 3 times negative 1 minus 6. Negative 3 times negative 1 is positive 3. Positive 3 minus 6 is negative 3. So my ordered pair is negative 1, negative 3. And again, we can check it. Negative 3 times negative 1 is positive 3. Positive 3 minus 6 is negative 3, which is my y. 2 times negative 1 is negative 2. Negative 2 minus 1 is negative 3, which is my y. Number 4, we're going to plug in 12 minus x for y. And set that equal to 2x. I'm going to add x to both sides to get the variable on one side. I'm going to divide by 3. And 12 divided by 3 is 4, so that is my x. I'll plug that in for y. I plug that in for x. Y equals 2 times x, which is 8. So my solution is 4, 8. Number 5. I'm going to plug this in for y. 2x plus 1 equals 2x minus 3. I have to get my variable on one side. 2x minus 2x is 0. That leaves me with 1. 2x minus 2x is 0. That leaves me with negative 3. 1 does not equal negative 3, so it is no solution. Remember, if it cancels out your variable, if you're left with a false statement, then it is no solution. And we know that if we have the same slope and different y-intercepts, then it's going to be no solution. Alright, number 6. Plug in x plus 1 for y equals 3x minus 1. I'm going to subtract x from both sides. And I get 1 equals 2x minus 1. I add 1 to both sides. And get 2 equals 2x. And when I divide by 2, I get the x is 1. Plug that in for one of the equations. 1 plus 1 is 2. So my ordered pair is 1, 2. Number 7. I do not have a variable by itself, so I'm going to need to isolate one. At this point, you need to pick a variable that does not have a coefficient. I'm going to isolate y, so I'm going to subtract x from both sides. Y equals negative x. I'm going to take this negative x and plug it in everywhere I see y in my second equation, because I need to use the other one. So that gives me 5x plus 2y, my y is equal to negative x, equals negative 3. 2 times negative x is negative 2x. 5x minus 2x is 3x. And negative 3 divided by 3 is negative 1. I'm going to plug that back into one of my original equations. That gives me x plus y equals 0. Add 1 to both sides. Y equals 1. So my ordered pair is negative 1 positive 1. And do the same thing for number 8. I'm going to subtract 2x because I want to get this y by itself. Y equals negative 2x plus 8. I'm going to plug in negative 2x plus 8 for every place that I see y in the other equation. So that's 2x minus 3y. Y is equal to negative 2x plus 8 equals 0. Negative 3 times negative 2x is positive 6x. Negative 3 times negative 8 is going to give me negative 24. 2x plus 6x is 8x. Add 24 to both sides. You notice I'm writing down every single step so that I don't miss anything. Divide by 8 on both sides. X equals 3. And I'm going to plug that into one of my equations. It does not matter which one. And that gives me 2 times 3 plus y equals 8. 2 times 3 is 6. Subtract 6 from both sides. And y equals 2. So my ordered pair is going to be 3, 2. Alright, for number 9, we need to isolate a variable. It does not matter which one we pick. I'm going to choose, the y right here. So I'm going to subtract 2x on both sides. That leaves me with 3y equals negative 2x plus 6. Divide by 3. Y equals negative 2/3 x plus 2. So I'm going to take this negative 2/3 x plus 2 and I'm going to plug it in for everywhere I see y in the other equation. That gives me 4x plus 6 times negative 2/3 x plus 2 equals 12. We need to multiply first. 6 times negative 2/3. The 3 and the 6, that'll make that 2. 2 times negative 2 is negative 4x. And 6 times 2 is 12. 4x minus 4x is 0. That leaves me with 12 equals 12. 12 does equal 12, so if your variables cancel out and leaves you with a true statement, it's going to be infinitely many solutions. And number 10, I'm going to get this y by itself, so I'm going to subtract 6x from both sides. That leaves me with negative y equals negative 6x minus 14. Divide by negative 1 on both sides. Y equals 6x plus 14. So I'm going to take the 6x plus 14 and plug it in everywhere I see y in the other equation. That gives me 2x minus 3 times 6x plus 14 equals 6. Negative 3 times 6 is negative 18. Negative 3 times 14 is going to give me negative 42. 2x minus 18x is negative 16x. Add 42 to both sides. That gives you negative 16x equals 48. Divide by negative 16. And 48 divided by negative 16 is going to give me negative 3. Plug that back into one of the original equations. And you'll get 6 times negative 3 minus y equals negative 14.